Hello. The statistical topic I have chosen for this video project is the Latin square design. In short, a Latin square is an n by n table with an n number of different symbols, where n is a variable number. The Latin square is set up so that each symbol is configured so that they appear once in each row and once in each column. The type of Latin square used in the following examples are in a three-factor configuration. Each row, column, and individual unit represents varying factors in an experiment or design. The factors configured in the rows and columns are blocking variables, while the individual units are treatment variables. The design of Latin squares can lead to a few pros and cons as well. Some of the pros would be that they can be a powerful tool in dealing with multiple varying factors that either cannot be combined or there is some desire to keep each factor separate. Also, Latin squares allow experiments to be relatively accurate with a small number of runs. The Latin square's simple geometry allows for a straightforward configuration. Some of the cons would be that the experiments must have three factors and each factor having the same quantity of n variables with a three-factor configuration. When using Latin squares, it is assumed that there are no interactions between the different blocking variables. Similarly, it is also assumed that there are no interactions between the blocking and treatment variables. These two can both potentially lead to inaccuracies depending on the experiment. In application, a three-factor Latin square can be used in an analysis of variance, most commonly referred to in this instance as a three-factor ANOVA, which would be used to gain a better understanding of the data present in the Latin square. This information can be crucial to the success or failure of an experiment. In this example, we can see how the Latin square design can be used in an engineering discipline. The example takes differing fuel types and engine types and tests their thrusts over a course of 3 days. Typically, this data would be then used in an ANOVA, where more conclusions could be drawn. In the rows, we could see different types of fuel used in the experiment. The columns display the day that the experiment was conducted. And lastly, the treatment variables display which type of engine was used in the experiment. Thank you.